Hi there and welcome. It's good to be with you. Welcome to the channel. It's a bit chilly down here where I am. That's why you see me dressed like this. In today's video, I thought we should slow down a little bit because we want to deal with some exciting linear programming. I do have a question here and it reads as follows. I will show you how this kind of problem can be dealt with using the technique of linear programming. All right. The question reads as follows. Students from Argentina and students from England are meeting on a cultural exchange. In total, there will be between 12 and 20 students. There are fewer than 10 students from Argentina, while the number of students from England cannot be more than 3 greater than the number of students from Argentina. Let's read it again and a little bit slowly this time. Students from Argentina and students from England are meeting on a cultural exchange. In total, there will be between 12 and 20 students. There are fewer than 10 students from Argentina, while the number of students from England cannot be more than 3 greater than the number of students from Argentina. Now, what is going on here is that there is a cultural exchange program between the students from Argentina and students from England. And so these guys are going to meet somewhere, but there are some restrictions associated with the numbers that can come and attend the cultural exchange program. Now, I have summarized the conditions on the board, and the conditions are as follows. First condition says the total number of students is between 12 and 20. This means that when we have added all the students coming from Argentina and the students coming from England, the total should not be less than 12 and it shouldn't be greater than 20. The second condition says there are fewer than 10 students from Argentina. Now, this strictly says that students from Argentina should be less than 10. They can't be 10, they should be less than 10. The third and final condition says the number of students from England cannot be more than 3 greater than the number of students from Argentina. Put simply, this means that if we subtract the number of students from Argentina from the number of students coming from England, the difference can be equal to 3, but it shouldn't be more than 3. In other words, the difference between these guys and those guys should not be more than 3. Now, our first task is, of course, to convert all this information into either inequalities or equations. But first of all, before we do that, let's agree on terminology. Let's agree on notation. What are we going to call the number of students coming from England? What are we going to call the number of students coming from Argentina? Let's call the number of students from England number of students from England. Let's call them E. So E students are going to come from England. Similarly, let the number of students from Argentina, AG, be equal to A. Right. Once we have agreed on this, we can now form our inequalities or equations, whatever the case may be. Now, the first inequality, it says here, the number of students must not be less than 12, because it says it's between 12 and 20, which means they can be 12, but not less than 12. So the first one says E plus A is greater than or equal to 12. Sorry, that's a funny one there. E plus A, because the total number of students is E plus A. Total number of students is between 12 and that. So E plus A is equal to or greater than 12. That's condition number 1. Condition number 2 is obviously E plus A is less than or equal to 20. So E plus A is less than or equal to 20, because this should not be greater than 20. Okay, So let's call this 1, 2. The next condition says there are fewer than 10 students from Argentina. So straight away, A is less than 10. We don't put equal to because it says it's strictly less than 10. The last condition, which is the third one, it says the number of students from England should not be more than 3 greater than the number of students from Argentina. In other words, the E minus A is less than or equal to 3. Okay, so that's 3 there, that's 2 there. Sorry, that's 4, sorry. I beg your pardon. Now we have converted all this information into mathematical language. What is left now is for us to plot the graphs of all these equations, shade the unwanted regions, and then we look for our solution in the remaining unshaded region. I am, of course, not going to be able to plot the graphs here. I will just sketch them for obvious reasons. Now, here is our axis. The vertical axis coming down here. And here is my horizontal axis. Let's call the horizontal axis A, representing the number of students from Argentina. And let's call the vertical axis E to represent the number of students from England. Let's nicely calibrate our axis. I'll put a 5 here. I'll put a 10 here. I'll put a 15 here. And I'll put a 20 here. Similarly, I will put a 5 here. I'll put another 10 there. I'll put a 15 here. I'll put a 20 there. I hope my numbers are visible because I made them a little bit small there, didn't I? Okay, right. Let's plot our equations. Now, when you have got an inequality like this, what you do is if you want to plot it, you replace the inequality sign with an equal sign. So this now is going to be like E plus A is equal to 12, right? So how do we do that? So when E is 0, what will be A? A will obviously be 12, somewhere here. Let me plot it in red. So it will be 12. Where is my 12? So my 12 is somewhere there. When A is 0, E is 12. When E is 0, what is A? A is also 12. There. So I can join my points. Let me see if I can get myself a ruler, a straight edge. Yes, yes, I do have a straight edge here. So I will join my points. Oh, it almost fell short. But anyway, there's the line there. Okay. That's my line representing the inequality E plus A is greater than or equal to 12. Now we have to decide which region do we want. Do we want the region above the line or the region below the line? What we do is this. We take any point. Let's take any point below the line. I will take this point representing the 0.55 roughly, the 0.55. Now that point represents E is 5, A is 5, which is 5 plus 5, which is 10. But 10 is less than 12. So that would not satisfy the inequality. So all points below this line don't satisfy the inequality. Let's check if the points above satisfy. You take a point, let's take a point 10, 5, okay? 10, 5, there somewhere. So that represents A is 10, E is 5. 5 plus 10 is 15. 15 is greater than 12. So all the points above this line satisfy the inequality. and the points below don't satisfy the inequality. So we will get rid of the unwanted region. This region is not wanted. All the points below the line are not wanted. Okay? Right. Let's go to the next inequality. The next inequality says E plus A is less than or equal to 20. Okay, we plot it as if it's E plus A is equal to 20, right? So when E is 0, A is 20. So there is our point there. When A is 0, E is also 20. Right, now I've got a problem. I'm going to have to try and be straight here. So joining 20 and 20 there, that gives me something like that, doesn't it? Oh, okay. Oh, so all right, there we are. There is my line representing the inequality. I drew it in black. Right. Again, which region do we want? Which region do we not want? Let's look at the region above this line. Take a point, let's say 15 and 5 is there somewhere. 15 and 5. Now, 15 plus 5, A is 15, E is 5. That represents 15 plus 5, which is, oh no, sorry. Let's take another point there. 15 and 10, which is there somewhere. 15 and 10, A is 15, E is 10. That represents 25. 25 is greater than 20. So that point does not satisfy the inequality. Let's take a point inside, perhaps 10, 5. A is 10, E is 5. 5 plus 10 is 15. 15 is less than 20. So all the points below this line satisfy the inequality, and the points above don't satisfy the inequality. So we get rid of the unwanted region, which is the region consisting of all the points above the line. I am plotting these lines as solid because this is an equal to or greater than or equal to or less than. Now we are coming to this one. We are going to make it a broken line because it does not include, the solution does not include the points on the line. Right. What is the line A is less than 10? Well, A is 10. The line A is 10 is this one. This is the line representing A is 10. It's roughly like that, isn't it? Okay, let's see if we can plot it. Okay, there we are. A is 10. It's a broken line, as I said, because it's just less than. So, okay, broken line, perhaps we can just extend it a little bit there. Right. Which points do we want? Points to the left are all the points representing A is less than 10. Points to the right are representing A is greater than 10. So we don't want points to the right. So we get rid of them. All the points to the right, we do not want it. Oh, my blue is just, let me see, let me just see if we can make it red. It doesn't really matter. So let's make it red, okay? So all this, we don't want this. We don't want that, right? We are left with one line to plot. E minus A is less than or equal to 3. So we will plot the line E minus A is equal to 3. Let's take some values here. When E is, let's say, 15, what will be A? 15 minus A is equal to 3, so A will be 12. So when E is 15, A will be 12. So our point will be, where is 12? 12 is somewhere here. 12 is somewhere there. So my point will be there somewhere, okay? Representing 15 and 12. Let's get another point. E is 10 or E is 5. When E is 5, what is A? A will be 2. So A will be 2, which is here somewhere. Right, so I now need to join these 2 points. Let's join the 2 points. Roughly, as I said, I am not plotting, I am just sketching the lines, really, just to indicate. This, of course, is a solid line because it's an equal to or greater than. So there it is. There's the line. Now, what region do we want? Let's take any point above the line. Let's take the point A is 5. And let's just take this point here. I think it represents E is 10 and A is 5. So 10 minus 5 is equal to 5, which is greater than 3. So 5 is obviously greater than 3. So we don't want this region. Let's test a point below the line. E is 5 and say maybe A is 8 somewhere here. So that will be 5 minus 8, which is minus 3. So minus 3 is less than 3. So points below this line are wanted. Points above the line, they are not wanted. So we get rid of the points above the line. Now, which region are we left with now? If you look carefully, we are here. It's this line and that line. And of course, this dotted line here. Remember, this is a broken line. We drew it broken and goes up to there and this part here. So roughly what we are looking at, the region where we are going to find the combination of the numbers of students from England and the numbers of students from Argentina is going to be found in the unshaded region here. Any point inside here will represent a possible combination. We can take points on this line. We can take points on this line. We can take points on the portion of this line, but we can't take points on the broken line because those ones are not included. The other point to remember is that we are dealing with numbers of people. We can't have 3.5 people. We can't have 8.35 people. We have got to have whole numbers of students from Argentina or England. So in other words, we must take discrete values of A and E. So you can only choose whole numbers inside this unshaded area. Roughly, I don't know, but perhaps things like 8 and 10 would do, 8 somewhere here would do, or whatever combination of whole numbers inside this box or along these lines will do. That for you is linear programming. Till we see you in the